But in one variable, excuse me, an equation in one variable. Okay, that's an equation where at least one expression has the variable. You know, you have one expression, then the equal sign, then another one. At least one of those two expressions contains the variable, whatever it is. Usually for us, it's going to be x. Again, if I go too fast, don't be afraid to say something. I mean, the notes I emailed everyone. So here's an example of an equation. 1 equals 2. Now, of course, that's a false equation because we know 1 is not equal to 2. But it is technically an equation. It's not an equation, though, in one variable because there's no variables there. Now, I'm presenting this vocabulary because it will come up again later in the course, if I remember correctly, but I do want to say it now. There is this notion of the domain of the variable in an equation. The domain of a variable, excuse me, in an equation. And by definition, that's just the set of all numbers for which both sides of the equation are defined. That's just what it is by definition. When I say set, I just mean collection or a group of. So it's the collection of all numbers such that both sides of the equation are defined. So here we have an equation in one variable. And of course, the right-hand side, there's no restriction there because there's no variables there. For the left-hand side, we have 7x plus 1, but you could put any number you want in for x on the left-hand side, and you get something that makes sense on the left-hand side. The equation might be false, but 7x plus 1 itself is defined for all numbers. So the domain of the variable in this equation would be all real numbers. Okay. As opposed to something like this. This is an equation in one variable. The left-hand side, there's no restriction. But the right-hand side, you can see, the right-hand side is going to make sense only for all numbers except 1. For all numbers except 1. Right? Because again, you never divide by 0. So the domain of the variable for this equation is all numbers except 1. Or you can write it this way. This is another way to write it mathematically. It's all x such that x is not equal to 1. I mean, the left-hand side, there's no restriction, which is nice. Yes?
So I'm a little confused on the domain. So like the domain for 2 equals 5 over x minus 1, the domain is x, right?
No, it's all numbers except 1. That's maybe the best way to say it.
So the domain is every number that's not 1.
Exactly, yeah.
Okay, thank you.
You know what, let me fix it. Let me fix that. I mean, what I have here is technically right, but let me write it better. It means all numbers except 1. There we go, that's better, I think. Right? Good question? Okay. All right, so that's a good question. Any other questions? Okay. All right. So for this one down here, right? This is an equation in one variable. I mean, it's a little bit different because you have the variable on both sides. Well, the left-hand side, as you can see, is defined, right? For every real number. You could, for all numbers, you can put any number you want in for x here, and you'll get something that makes sense. You could add 1 to any number you want. Okay, so the left-hand side is defined for every number. The right-hand side, though, that's a little bit different. I mean, in this class, what am I doing? In this class, we only take the square root of a non-negative number. Okay, we don't take the square root of a negative number here, because then we're going to have what are called complex numbers. We're not studying those in this class. So the right-hand side is defined only for numbers greater than or equal to 0. Okay, the left-hand side is defined everywhere, for every number. The right-hand side is defined only for numbers that are greater than or equal to 0. So the domain has to be all numbers that are greater than or equal to 0. Let me just write that, because, I mean, I wrote with the x here, but let me just fix it just like I did with the previous one. All numbers that are greater than or equal to 0. You have to be how do I say this? You have to be defined for both sides. That's what I want to say. You have to be defined for both sides. Okay. All right, now let's get to more equation stuff. So for this one here, notice the domain of the variable here. Of course, it's all real numbers. There's no restriction on the right side. On the left side, though, okay, there's no restriction either, actually, because you could take any number you want, multiply it by 2, and add 1, and you'll get another number. So here, the domain is all numbers as well. But let's start plugging in numbers in for x and see what happens. And we'll do that right now.